I'm ready.
Welcome everyone. This is our new episodes on science, technology, robotics engineering, solar energy and many things. And this man actually is a brilliant mind, one of the talent man from USA. He do work for NASA and he have a lot of creative technology and many more things. Perhaps our young people, our policymakers, universities, corporations, they will learn many brilliant things from him. So can you introduce Mr. Matthew about you, your job and everything?
Yeah. So my name is Matteo. You can call me K if that's easier to pronounce. I am an engineer at Robots Everywhere LLC, and we basically do bespoke engineering solutions. We're one of the very many engineering consultant businesses that are out here in the North Bay. We have done a bit of work for NASA. We have done a little bit of work for OSHA. We have done work for the shipping companies out here. Basically, our business is to be inventors for hire. We also sell retail a little bit. We sell stuff on Amazon, but I'm not here to advertise. Most of everything we do, there's some stuff we can't, is actually available open source on our wiki. So you can just take our designs, and as long as you're not doing it commercially, you can copy them.
Very interesting. Actually, engineering is the best important part right now. And how, because we have many youth and everyone, how they develop themselves. We want to know your story because by this way, maybe many people, they become motivated and they can learn from this session. And most importantly, we will observe your projects. This is very interesting for our show.
My story is actually very simple. I don't think that there is very much to tell. I started doing electronics when I was 13 years old. I was kind of bored in school. So what happened is that I made friends with this PC repair shop owner. And in the afternoons after school, I would go there and repair, old PCs and stuff like that. He would pay me in parts basically. So what I did with all that is that I ended up building a little game arcade in an unused coal room that we had available. I did that. I got out of high school. I actually worked at that shop for a couple of days after that. Then I got a scholarship at university, at a Texas university. I went to Texas. I got my degree over there. Got out again. I worked a little bit for a survey company. We were doing GPS systems. We built an autonomous boat. This was 2008, so that was pretty advanced stuff at the time. And I went to Stanford a little bit. I got out of Stanford because grad school wasn't for me. Hey, if grad school is for you, go for it. If grad school is not for you, don't feel forced to, get a PhD. A PhD opens a lot of doors, but it's not something for everyone. Some people prefer to take the practical approach, and I happen to be one of them. So after Stanford, I ended up doing a little bit of freelance work. In 2010, I was contacted by Will Marshall. Then he was working at NASA. Now he's working at Planet Labs. They actually launched a bunch of satellites yesterday, and I did a bit of work there. We worked on PhoneSat. We did the first Android robotics system, the Antbot. This is 2010, 2011. And we've been working in that field ever since. The major milestones for us was a chlorophyll detector for Dr. Chris McKay at the NASA Ames Research Center in 2016. In 2014, we made the El Cheapo laser cutter, which you can find. Just look it up again. I'm not here to advertise. And most recently, we've been working on a micro drill for Martian soil. And one thing I'm going to do for you is that I'm going to show you the preview for the prototype, and that's something we have not shown before. It's not on our YouTube channel yet.
Yes,
so that's
brilliant.
something you get to see before everyone else, I guess.
Yes.
Most everything we do is open source. So we have a wiki. and you can look up everything. You can look up everything we do over there. We just show you what we've been working on.
Brilliant. One specific things, like example, you are working with NASA as well as you are solving many problems. So at present situation, do you have any specific project in COVID-19 period, or you are trying to produce something, or do you want to share with us something about that?
Yes, we have been working with Guy Cavalcanti on the open source COVID-19 equipment project. You can look it up on Facebook. There's a Facebook group. It contains approximately 75,000 makers all over the world. And what we have been doing is that we have been creating a repository for personal protective equipment, and face masks, face shields, stuff like that. We came up with a face shield design that was approved by the NIH for small scale production. And I'm gonna see if I can show you it actually, because it's kind of interesting. So what we did is that we worked out that you can use table salt and fizzy water, carbonated water, to create a micromesh that can be used for non-medical grade masks. And since the tissue is impregnated with salt, and the carbonation gives you this micromesh for the salt, so you get like basically you're bubbling the water, and then the salt kind of fossilizes it in place. The result is that you end up with a breathable filter that will trap some of the particles, and most importantly, will auto reset, because, as you know, salt just picks up humidity, so it will suck the water out of the virus and eventually self-reset it if you leave it on dry air. Everything we have done in that sense is, again, free to download, of course. The mastermind behind the project was really Guido Canti. We have a demo to show for, and that's something that my partner Riley August did. He did a fantastic job with this filter. You can go to our website with the wiki, and I'm going to post the link in here if you like.
Yes, definitely.
Yeah.
Our audience, but like he has many resourceful things. We will share it in our group. So whenever you need any kind of solution, whatever it is, you can see on his YouTube channels and many more things. Yes.
There it is. It's Robots Everywhere Wiki. Again, most of what we do is free. You just download it, you print it. We have, for PPE, we have this thing. We have a number of other options. For example, this is how to make a positive pressure PPE suit. This is for health workers. And you start with a snorkel mask and 2 painter suits, and we have the instructions on how to build it. Now, this is specifically designed so that the high school student can build it. So you don't need to any kind of advanced metal work or advanced soldering to be able to make it. You just have to use like a regular soldering iron and know how to use hot glue and filter. This is a 3D printer spool that was left over, so we use that for our frame. And this is for an air mattress. The idea here was to design something that could be built with things that are easy to buy, because my thinking is if you cannot access the materials you need, there's no point. It doesn't do any good. So yeah, that's what we've been doing for the COVID-19. We have been providing local hospitals with face masks, face shields. This is an example for one, if you quickly see it. Again, this is also very simple. You see that it is made out of things you find at a stationery store. This is a 3D printed part. You can download, of course, the schematic for it. And unlike the ones that are laser cut that you need Lexan sheets, this is something that you can get from a sheet protector. You can just buy this at your school supply store. And you just reuse that. The 3D printed part is made out of polylactic acid, PLA, so it can be microwaved. The idea is that you bunch it all up like that, and then you unfold it like an origami, and when you do, you end up with a nice and clear piece of plastic sheet. This is another thing that we make available. You can just go on the website and download the schematic. This
Mm-hmm.
particular thing here has been developed so that it prints in batches. You can print 4 or 5 at the same time. And the reason
Mm-hmm.
for that is that if your school or if your makerspace or your home has a 3D printer, you can print a bunch of these over 8 hours at night, so that you start the print when you go to sleep, and when you wake up, you have 5 of these
Mm-hmm.
without having to get up and change the build plate.
Mm-hmm.
The idea being this is a simple solution. It's not the optimal solution, but this is something that you can make a lot of using only one 3D printer. But one of the things we're kind of proud of is that we were able to give this to to hospital in back home in Italy.
Mm-hmm.
We were able to send them a 3D printer
Mm-hmm.
because they didn't have one, and show them how to start making these. And
Mm-hmm.
they were able to remain open, to keep the hospital open, because instead of having to request supplies from the central government, they could make it themselves.
Mm-hmm.
So that's our COVID-19 response.
Okay, very good, very good. We have many people, countries like from developing nations like India, Bangladesh, even Nepal, Sri Lanka, even many countries, even Africa. We have. Look, if the country like this kind of countries, hospital and these things, they want your technology and other things for solving this COVID-19, you can help them, right?
Absolutely, we're very happy to help. These are all our free
Brilliant.
designs, by the way.
Brilliant. So all of the things actually designing by yourself, or you have your own team and others people as well.
What we have is there's me and there's Riley doing this work, and
Mm-hmm.
I'm gonna show you how. That's Riley right here,
Mm-hmm.
and he basically does all the software stuff,
Okay.
and I do the hardware, and we both do the mechanical engineering when
Mm-hmm.
it's simple enough. It's important. See, the problem is that today it's all about specialization. Everybody wants to be a specialist. We need
Exactly.
specialists, but we
Exactly.
also need people who understand a little bit of everything. Because, for
Mm-hmm.
example, I went to school for electrical engineering.
Mm-hmm.
Riley here went to school for software engineering.
Mm-hmm.
We have worked with Reason Bradley of BattleBots for mechanical engineering stuff. We also work with, but for example, the problem is that it the fields are very specialized. So a hardware engineer sometimes has difficulty talking to a software engineer. They
Understand.
do not speak the same language. So if you have 5 or 6 engineers in your design group, there has to be one person who knows a little bit of everything, so that they
Mm-hmm.
can talk to everyone else. And this person does not necessarily have to be a manager. They can
Mm-hmm.
just be the person who acts as a bridge. And
Mm-hmm.
this is necessary because we have pushed very hard to get our schools to get good specialists. Specialists are very important, but
Mm-hmm.
you need somebody to act as the glue. Are you familiar with the expression glue logic?
Yes. 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 Mm-hmm.
Somebody has to be the glue logic.
Yes. 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 Definitely
And this is
understand.
a role that a lot of companies and even a lot of universities neglect.
Mm-hmm.
My personal preference, of course, I'm Italian, so I studied the work of Leonardo da Vinci.
Mm-hmm.
That guy was a genius. He could do everything. He could do engineering. He could do painting. I'm not that good, obviously. Nobody is.
Mm-hmm.
But I took the time. Again, I started off as an electrical engineer. I took time to learn some software. I took time to learn some mechanical engineering. In that
Mm-hmm.
sense, for me, having a 3D printer was an absolute godsend, because having a 3D printer means that you can think up a simple design and you can just generate it. You can just build it. You
Mm-hmm.
click the button and you wait for hours and they get there. And at this point, a 3D printer costs $200. It's
Mm-hmm.
not a major investment. It's something that every high school should have one. Every community college should have one. Uh,
Mm-hmm.
my 3D printer in particular paid for itself the first week, because what happened is that the day after I bought the 3D printer and figured out how to connect it and use it, my dishwasher broke.
Mm-hmm.
And it's this old dishwasher. They don't make the parts for it anymore, so I was able to get the part out and pre-print it and just get it back to work. And frankly, the dishwasher would have cost more than the 3D printer would have, the 3D printer cost. And this was in 2014. Now, 2020, 3D printers are commodities. You just buy one. They're cheap. They're available. Filament is available. We do have a filament producing system in here. So we make our own filament, but that's not strictly necessary. You can just find it. Any questions?
Yes. Okay. One specific things, like example, when you build up your projects, you have any pre-plans or how you actually your thought process actually work when you do this kind of engineering projects, or you just fulfilling the corporate demand, or
Okay, that depends. Creative engineering is very important for us. You need to give your engineers a bit of freedom to tinker. So this, for example, is a plasma cooker that we made out of a damaged microwave. This is actually us cooking a hamburger with a 500,000 volts of electricity. And why am I showing you? So I'm showing you this because this was a complete spur-of-the-moment project. What you want to be able to do is that you want your engineers, this is something intelligent that Google was doing. I don't know if they're still doing it. I hope so. You want your engineers freedom to tinker. That is, you get 4 days a week to work on the project that pay the bills. And then 1 day a week, or even just an afternoon a week, you say, okay, here's a bunch of parts that we have left over from other projects. You have complete freedom, just mess with it, do whatever you like. And then you make sure that they can develop their ideas. And again, this is something that Google was doing earlier in the decade, 2010, 2012. I think they've kind of stopped now. And that's terrible because many good ideas in history have happened by, I'm not going to say by accident, I'm going to say by serendipity. For example, you can see here the cooking. For example, WD-40, WD-40, the lubricant, right? So WD-40 was supposed to be a lubricant for a rocket nozzle pump, and it didn't do very well at that job. But it was an excellent water displacer. So they just decided, okay, this is the water displacement formula, 40th attempt. That's where the name comes from, by the way. And that just became their main product. We built the El Cheapo laser because we wanted to be, because a friend of both me and Riley wanted to do engraving on her origami. And we built her laser. She really liked it. At the time, they were not really widely available, and it became our most popular product. And that's just what can happen. My point here being, you need to be able to do both. You need to be able to serve the needs of industry, and you need to be able to just kind of tinker on a whim. If you limit your engineers to just doing what they're told, you will end up with engineers who can do nothing but what they're told. And that's terrible.
Yes. Yes. One of the important thing what you are talking about, the innovation thinking. So how engineers can develop their innovation thinking, and how we can understand your grow the innovation of the young generation.
That's the hard part.
Okay.
Creativity is going to be the next big arms race of the mind, because what has happened is that historically we had societies, we had countries trying to develop a good industrial base. Then we had countries and societies trying to develop a good, engineering programming base. That's where we are now. The next step is finding a way to consistently get creative people, because that's going to be the next advantage. It used to be that you needed to be very methodical. For example, when you do circuit design, now you can just hit automatic for a circuit layout, for example, and it will just do it for you. All those low, all those high effort, low creativity intellectual tasks are being automated. They are they're basically what the factory work was 100 years ago. No, you had people doing crafting, you had people doing craftsmanship, and then that became automated. You had people drilling holes in planks of wood to make ships, and then we got power drills. The next step is we have these things here that just do our layouts for us. They can do our coding for us. So you will need the next big arms race, if you want, is how to get creative people out of school, how to get people to learn. That is very difficult. I know I've told you this. I know you want to know how. Now, if I had a recipe, believe me, I would share it with the world. What I do have is a couple of suggestions that apply to how my life went. When I was little, I was told, you can read everything you like. We will not censor whatever you want to read. So, for example, at age 11, I was reading 1984. I was reading Dune. I was reading The Animal Farm. Even controversial works. And I remember one time my elementary school teacher caught me. I finished my classwork. I had brought a book from home, Dune, the sci-fi story. And I started reading it because, I was done with the classwork. And she got really upset, and she called my mother and my grandma, because my father was working at the construction site. He's an architect, by the way. And they came over, and my teacher said, your kid is reading this thing. This is not appropriate for a child because it has nudity, it has war. And my grandmother, she got really angry, and she said, I grew up under Mussolini, and they would censor everything we did. And now we're a free country. They don't do that anymore. So if he is smart enough to read adult books, like sci-fi or history at age 11, you should not interfere. You should let him. And that is one of the greatest gifts that my extended family has given me. The other thing that I am very lucky about, and this is something that I think you can appreciate better than Americans can, for example, is I grew up in an extended family. I grew up in a big house with, my mom, my dad, my cousins, my uncle, my aunt, my grandmother, my grandfather. And that meant that there was always somebody around. So we never really lost the connection to family. And this is corny. I realize this sounds corny. But when it comes to creativity, it's important because you got a big house, you got a bunch of people around it. You will find problems. You will find solutions to those problems. And that is the best way to develop creativity. You just put yourself in a situation where problems exist, and you tell yourself, okay, I'm here. I got to solve them. I'm going to go on a boat. I'm going to go on a sailboat. I have no idea how to sail. I'm going to learn how to sail. And while I'm there, I'm going to learn how it's done. And, 10 years later, I made an autonomous sailing boat. So if you want to be creative, don't get in a situation where your life is on autopilot. Don't settle into a routine. Or if you do, because, people like their routine. If you do, give yourself room to get out of it. So this is our autonomous boat. This is something I built in 2008, and this came out of a love for sailing and a love of technology. The thing is that what is crippling to creativity is being told this has already been invented. What is crippling to creativity is being told nobody needs this. There's no market for it. You don't know that. We built some of the stuff that we built in 2012 have a market now. They've just been sitting there for 8 years. And that's just how it's worked for me. If I had a universal solution for creativity, I would love to just give it to the world on a silver platter, because that is the next big challenge that we have as a species. We have solved factory productivity. We have solved office productivity. The next step, I believe, are creativity and, if I may say so, wisdom. One book that I would recommend for that is The Shockwave Rider by John Brunner. You can download it on the Internet Archive. Just look up Shockwave Rider. Read that book. It's a very nice sci-fi story, and it makes that point about creativity and wisdom. Then after you've read that book, look at what year it was published, and it will blow your mind.
Yes, understand. One important thing is that as you have a creative mind and many things, so we want to know more about your NASA projects, how you work, how it go, like actually how you do work for them, because maybe with many brilliant people we have, they maybe understand how you work with the NASA and
So I
specifically
am
your
not.
project.
I'm not an NASA engineer. I do not. I'm not a NASA employee. They do not pay me. I am a NASA contractor in the sense that they will sometime come to me and tell them, "Hey, can you design us something?" And I will do it or not do it. And this is my choice. I was actually offered a job there, and I said no at the time because I wanted to be able to do other work. And also because I felt that I should earn it. Now NASA, they were very kind. They helped me get a my green card. They helped me immigrate to the United States. So yes, one thing that I want to specify is if you're good, especially if you do aerospace work, they will help you immigrate. So this is one of the projects we've done for them. This is a chlorophyll detector. So the idea here is that this was an instrument designed to go on the next Mars rover, which we don't know if we're launching or not at this point. And the idea here is that it's supposed to detect chlorophyll in the soil. There is already now. One thing that's important is that the Mars rover already has an instrument for this. It's a robotic arm with a Raman spectroscope. This instrument that you see here is a much worse version because it's not nearly as sensitive or powerful. The advantage it has is that it's simple and it has no moving parts. So there is very little on it that can break. One of the things that is very important when you do nautical work or aerospace work is it has to be reliable. It has to keep going for years and years without breaking. So the idea with this one is that you use this to scan for a site that you might find chlorophyll at. Okay? And if you find something, then you deploy the arm, and the arm has 17 motors on it, and if any one of them breaks, it will basically stop functioning. This is just a near ultraviolet laser and a regular webcam and the Parallax propeller chip, which costs $8 for image processing. It's a very simple system. I have found that when it comes to industrial things, nautical things, even aerospace things, the simple solution has a lot of benefits because it will work. There is very little that can go wrong. That which does not exist cannot break. So, for example, this can tell apart whether there's you see, these are various green objects. One of them has chlorophyll. One of them is a leaf that has chlorophyll in it. So what we do is that we came up with a simple image processing system that can detect chlorophyll. And the idea here is that this will allow the Mars rover to skip most areas that don't have anything in them. And then when this little guy finds something, it says, okay, there may be something here. We have a maybe positive. Now that we have a maybe positive, we deploy the good instrument that is fragile and risky to deploy because now it's worth deploying. This gives us a little bit of redundancy. So that's one of the projects we've done for NASA. This is me actually showing how the system works. You can see here it's aimed at the chlorophyll. And the idea is to make it so that it reads other green objects but can discern them. The other thing we've done in aerospace was the phone set project. So we took an Android phone and we used the guts of the Android phone to operate a CubeSat. Now, everybody's doing CubeSat these days. This was in 2011, so at the time it was a new thing.
Mm-hmm.
You can see the histogram here.
Mm-hmm.
The third thing we did, and again, I would like to save that for last, is show you this is a micro drill that we have developed to look for potential signs of life in the salt basin on Mars. And the problem there is that you need a drill that needs to dig into the soil, right? So it has
Mm-hmm.
to be heavy. But this goes on a lander. It cannot be heavy because space stuff can't be heavy, because the more heavy it is, the more expensive it is to send it into orbit. So we
Mm-hmm.
had to come up with a solution for that.
Mm-hmm.
My advice for that is learn your history, but be
Mm-hmm.
prepared to go beyond it. I cannot tell you how much of this was, conscientious study and how much of that was just spur of the moment tinkering, because the truth is you need to be able to do both. There are times that you need to be able to make that leap of creativity. There are times that you have to sit down and do the math and study what came before you. And you're not a person who can do both things reasonably well will go further than a person can do one thing extremely well.
Mm-hmm.
You've got to expand your range. Don't over specialize.
Mm-hmm.
Um, I understand that the industry today, see, that's your image detection there. See the little square? Now, again, this is done with an $8 chip. There's no, there's no microcomputer here. This is just a simple controller. Why? Because it's simple, because it uses little power, because it's reliable. So this is a creative engineering effort. This is
Mm-hmm.
something that we did because it was asked of us. Some of the things we do is because we felt like it.
Mm-hmm.
And my point remains: get good at many things. Then find the one thing that you like and become excellent at it, of course, if you can. But my point is, it's easy to find a job if you're a specialist.
Mm-hmm.
But if you want to do the fun stuff, you're better off being a generalist. We need generalists. We need people who can see beyond the narrow scope of their specialization. Now, of course, in order to make a living, you're going to have to be good at one thing, but don't disregard the other things just because you're not good at them. I tell people, have a hobby that you're terrible at. For me, it's sewing. I make, I sew. I fix clothing. I am bad at it. I don't care.
Mm-hmm.
Anything else?
Yes. So already there is an audience response. Humaira Tanzila from Malaysia. She said, excellent work. I think people are observing your things. Another interesting thing, like side by side, you said that you are developing project for solar and this kind of things. Can we know the combination of solars? And we want to know about robotics engineering as well.
Okay. Well, our business is called Robots Everywhere. So
Yes.
robotics engineering is interesting because if you come to it from a software perspective, you will find that a piece of software that works perfectly in a simulation does all
Mhm.
sort of messy things once you deploy it in the real world. For
Mhm.
example, here's something we built. Here's something we built in 2009,
Mhm.
and this is one of our ant bots. This is a very simple wheeled platform. You can
Mhm.
put a phone on it, and it will operate using the phone. Or you can put, in this case, there's an 8-core processor, and this is actually the same processor that we used for that Mars thing you saw.
Mhm.
This is running using a genetic algorithm. So this is actually learning how to move. You see that it's kind of moving tentatively,
Mhm.
and this is actually adapting its programming as it goes. This was pretty interesting build. Again, for everything there is a source code for everything we do. You can just download the schematics for this. Our robotics work has mostly been autonomous vehicles, so long range vehicles. It could be like this little guy. It could be, for example, robotic boats that are used to scan the bottom of the Bay Area out here. We like to think that we have done pretty much everything. We've done boats, we have done airplanes, we have done everything except quadcopters, because everybody's already doing quadcopters. So this is generating a map of the seafloor as it moves. What do you need to know for robotics? Again, keep it simple. Now look at this guy. This is a fully autonomous robotic survey vessel. You can either remote control it, or you can let it steer itself. It has only two moving parts. It has one motor here. It has another motor here. And that is all that moves. Everything else, there's a GPS here and a compass. This is where the batteries and the controller are. There's a sonar underneath, obviously. Why does it only have two moving parts? Because it's simple. If you take something like the Boston Dynamics Big Dog, which is a beautiful thing, it's also very complicated. It has, I think it has 18 or 24 degrees of freedom. It's really cool, but consider, so the Italian army was looking at buying one of those, and they put it against a mule, and they decided to keep the mule because, you know, a Boston Dynamic Big Dog costs a few $1 million. Now, if you need to make, but if you need to carry stuff, a mule, you just need a horse and a donkey to make more. And this is something that I think we should keep in mind. So, because the most high-tech solution is not necessarily the best one. What's the best solution? Nobody knows. You as an engineer are the person who has to make that determination. But, and here's the kicker, sometimes the best solution sometimes is the simplest one, sometimes it's the cheapest one. It is always that which works. And I understand that's an oxymoron. So this is the same little robot with a cell phone on it. Now this is a cat here, and she was sick. Okay, unfortunately we had to put her to sleep about a week after this. And this is a little robot, and this is a person. This is the previous owner of the cat saying goodbye to the cat remotely because quarantine. Again, this is also something. This is all 3D printed. You can just download it. So when it comes to robotics, my suggestion for everybody is to keep it very simple. You don't have to use legs if wheels will do. You don't have to use a complicated gripper if a vacuum system will do. Don't be afraid of your robotic system solution looking messy, because that which impresses people when you do like a PowerPoint or a presentation for investors is not necessarily what works. This was a solution. It was cheap. It was like $30 in parts, and it worked. You cannot just decide that just because something looks shiny, like everything wants to look like an iPhone right now. Okay? But it has to work, and that's more important than what it looks like. It's important that this be maintainable. So the circuits are here all outside because we want people to maintain it. Now, you can't hear the audio here, but this is the cat. So this is a sick cat, okay? She recognized that the previous owner was running the robot, and now she's kind of trying to play with it. That's how you know it worked. The litmus test for a robotic solution that works is, can people use it, not how fancy it is. Hey, you want to do fancy stuff? Go for it. Nothing wrong with it. But I would rather have something like this than, you know, some big impressive system that then becomes too big and scares the cat. Because the important thing here is not, hey, we made a robot that you can drive from Australia to California and it costs only $30. The important thing here is somebody got to say goodbye to their cat. It's important to not lose focus on that. Other things, for example, this is a, you know, if you want to get fancy, get fancy. This is an ice cream maker. This was designed to be biomimic. So there is a brain controller and there's a spine controller. With each vertebrate that controls one motor. And the idea was to mimic the nervous system of a worm. Because, frankly, the customer was okay with it. We had fun doing it. The idea here is that you have to be able to move a large number of motors and stuff. Well, there's a gear motor here. There's a servo here. There's a bunch of steppers down here. And we had to come up with a controller that could do all of these, and we did. One of the things that, in this case, we wanted this thing to look a little whimsical, a little kind of like Willy Wonka. So we actually went with something that is impractical, but it's cool to look at because that's part of the experience that we wanted to give the people who buy ice cream. So, for example, instead of having one motor per, this is like sprinkles, chocolate, and stuff like that. So instead of having one motor per each, which makes more sense because it's a motor, they're cheap, we had actually a little hand that goes between them like a person would. This is mechanically more complicated. So you see it move? And this is mechanically more complicated than having a chute. But the idea here was to give somebody the experience of seeing the machine work. And if you just have a bunch of motors, it doesn't really show you anything. We want people to remember that machines are cool to look at. The problem is that you go to a vending machine; it's very anonymous. The idea here was to do something that, hey, this is how it works. We are not ashamed of showing you the gears. We're not ashamed of showing you the wiring. We don't want you to be scared of it. We want you to understand that these machines don't work by magic. They work by somebody who built them, somebody who designed them. They do their thing. This one in particular, again, this is biomimetic because the fact that we had this, again, overcomplicated system for delivering the ice cream toppings meant that it had to be at least able to self-adapt a little bit. If it makes a mistake, so instead of having a machine that doesn't make mistakes, which is what you want in an industrial context, in this case, we wanted a machine that could make mistakes, but could also correct them. You can kind of see it here when it moves this thing, and it doesn't quite get it right, and it adjusts itself. So yeah, that's one type of robotics, and I think that, of course, if you do this for an industrial system, it will require efficiency. But stuff like this is useful because you want people to understand that technology is not magic. This is something somebody made. And you see a completed product. You see a completed cell phone. You see a completed Tesla truck. And they're kind of intimidating. They're kind of scary looking. You're like, this is perfect. Somebody perfect made this. I'm not good enough to do it. And now we want to send the message, no, you can't do this. This is something that's easy to build. You can make your own technology. Even if you're not an engineer, technology is not something that owns you. Technology is something you own. For example, that's why none of our products have a subscription service, and most of our products are open source. Simplest example. This is a solar charger. Since you wanted to do solar stuff, I'll show you some videos later. I want you to look at the schematic. Look at how simple it is. This is a single Zener diode. This is me telling you what it is, what diode it is. This is me telling you where to buy it. I don't know if it shows in the video. There's if you scroll the page down, there's a link where to buy it. You can just get the damn thing. And this is me saying, okay, R1 and R2 can be pieces of twist tie wires or chicken wire even. The point being, you need a little bit of resistor here. It doesn't have to be accurate. This is a 4.5 volts or 6 volt solar panel. This is one diode. These are two current limiters. And this is your USB port. You can use this thing, this very simple thing, to charge your phone. Now, when do you want to do that? When you have an emergency. I have had literally homeless people come to my house and be taught how to solder and make these things. Then they take them home, or well, they take them to, wherever they pitch their tent or whatever, and now their phone is usable. One of the things that had happened here with the quarantine is that homeless people were unable to go to bars and stuff to charge their phones.
Mhm.
So, for example, if they got a job offer, they couldn't answer it because their phone was dead.
Mhm.
And this is a simple solution.
Mhm.
As for solar stuff, let's see what else we got. Yeah, we've built a couple of solar boats and stuff like that. Unfortunately, they're kind of old, so I don't have a whole lot to show you there. We're currently building a solar electric bike that we also released the design for free. One of the things we're doing today, in fact, is we're doing this virtual hackathon about using LoRa and Bluetooth to set up a mesh network to have a low speed, so only texting, low speed secondary cell network for when the main network goes down because there's been an earthquake or a fire, which, I live in California. That's kind of important for us. I am very sure that it will be important in other parts of the world, because imagine that you have a cell phone tower that is the size of your fist, and it has a solar panel you can deploy. Let's say that there was a storm or a hurricane. You get them out of storage, you put them around, and all of a sudden your phones work again, and you can text. You can't call because they're not fast enough, but you can at least text and tell people you're okay, or coordinate drinking water or food that need to go somewhere. We will have, and unfortunately, you catch me today because we just started working on it. We will have a sample for it. Now, this is the NASA project that I was gonna show you. This is gonna go on Mars, and this is actually something that I believe that shows our engineering philosophy very well. It's light, it's simple, it's perhaps even too simple. You look at this, it looks like something that has been designed by college freshmen. But that's the point. It's small and simple. This replaces an instrument that was designed by people who have spent about $500,000 on it. This cost $60. So you can see here, this is a spring. Now, this is, of course, going to be put in position by a mechanical arm, not by my finger. But I like that you can see my hand because you can see how small this is. This was 3D printed by a resin printer. These are 2 sewing needles. This is a motor. There's a little gearbox here that I can't show because my finger's in front of it. And this is just a spring. And this is just chicken wire. The whole thing runs off a quadcopter controller. Super cheap, super simple, super light. The point is that it lands, and then it has to push itself into the rock. So we pulse this motor, and maybe you can actually hear it.
Yeah.
We came up with this this particular tap 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 waveform by trial and error, and you see that it has embedded itself in the rock, and that is sufficient to test the conductivity of.
Yes, Mr. Matthew, we are actually observing your videos. So if there are any issue with your mic, you can come up in the show
Can you hear me
and
now?
you can explain. No problem. Yes, yes.
Okay, great. No, I was just saying, this is a simple, light system. It is more likely to fail than a heavier, more complicated system. However, the point is that you don't have one of these, you have 10. And let's say that 2 fail, you're still getting data from 8 locations instead of just 1. These are design considerations that are important. Do we want to do something light and disposable like a swarm of ants? You don't care if one ant dies. Or do we want to do something complicated and elegant like, I don't know, like a big cat? I cannot tell you these things. The individual engineer has to make this determination. Now, and I say the individual engineer instead of the team because at the end of the day, That's something that everybody has to think about. Then you get together with your team and decide. Now this is me kind of slamming it around so that to show you what it takes for it to get dislodged, because eventually you're going to want to pack it up and move it away. Yeah, this thing here weighs 60 grams and replace something that weighs 2 kilograms. And in aerospace, that's a big deal. That's a big weight savings. If you have any other questions?
Yes, basically my question is that, example, let's say I'm from Malaysia, so there are many developing countries students and young people. So example, how your projects, like you have a project from NASA, you have a solar project, you have autonomous vehicles and many more things. So how you can integrate it with these things with the Asia Pacific, or how we can make a breathing in between us? What are your guidelines? How do you think?
How do you make it
A
breathing?
breathing, like example, in between your projects and example in Asia Pacific, how we can work together actually.
Okay, collaboration is difficult. It's been made more difficult by the fact that everybody's kind of stuck at home right now. How can we interbreed these projects? The main thing is that as if you tackle a variety of projects, again, that's why I say have a hobby that you stink at. As you tackle a variety of projects, your mind is going to grow in the direction of flexibility. So the more kinds of projects you tackle, the easier it will be for you to talk to people who are specialized in that kind of project. I 5 years ago, I knew nothing about laser design, but we wanted to make lasers. So I taught myself. I went to experts. I learned. I tinkered. I experimented, and I learned from that. Am I a laser expert? Absolutely not. I am not a laser expert. Am I able to talk to a laser expert and learn from them without wasting their time now with what I have studied? Yes. And this is something that we need. We need people we need specialists. We always will need specialists. We need people who can talk to a variety of specialists and get them to work together or take their results and integrate them. We need these things.
Yes.
Already.
Yes.
Go ahead.
Muhammad Shohel Rana, he's also supporting us a lot. He said it's a very inspiring. Humaira Tanzila said it's excellent work. People love your work. Let's carry on. Let's carry on your project.
Thank you very much. One of the last thing I want to say is, if you want to look at our work, it's Robots Everywhere. And I suggest that you go to our wiki. And there we go. Everything we do, except some of the NASA stuff, because we have to, clear security and everything else, is available here. You can find schematics. You can find you can find schematics. You can find our software, and it's all free.
Brilliant.
So take our work and integrate them into your projects. Don't be afraid to tinker, and if you come up with something cool, please, send us an email, because we'll put it on your blog. We'll put it on the blog.
Yes, brilliant.
That's really it. This is this is last thing. So for COVID, we took an astronaut costume and we converted it into a positive pressure suit. And this is actually something. See, remember this? And this is actually something that you can use in a hospital. And the idea here was, let's take a costume, let's take something fake, let's take something that has to appear and turn it into something real. Why? Because you get this a costume like this, you put a nurse in it, it's less intimidating. Let's say you got a sick kid, they're probably gonna appreciate it. Anyway, that's pretty much all I got.
Mhm.
Anything else?
Yes, one of the things, like we saw a lot of your projects and your things. If you want, you can come to camera and we will discuss about something about motivational aspect, because already people coming, like if you help them to understand your thought process, the motivational aspect is very important, because we have many young people. How can I tell you? Let's say we have already 200,000 students. We have a target that we will reach 1 million people by 1 year. So let's say you are a brilliant mind, you do a lot of projects, you try to come up with the innovations and technology which is actually changing around the world, and which is very important, because I also visited many countries, I integrated with the root level students and many more things. We want to know, like if a students want to change their self, like what you say, like 5 years before, maybe for laser technology you do not know nothing. So how you actually build up your enthusiasm, your positive approach, your dedications, you are definitely hardworking, you are creative, how you build up yourself?
I don't. I do
Okay.
not do that. Very
Okay.
simple. I actually suffer a little bit. I actually have a little bit of an issue with depression, and
Okay.
to me, building technology, building things that will last, is a way to know that I am making a difference. Because it's like the thing with the robot and the cat. It's not really about the robot at that point. It's about the cat, and it's about the person who wants to say goodbye to their cat.
Mhm.
If you want to become creative, expose yourself to a lot of things. If you want to keep your motivation up, at least for me, what matters is this is the part where you kind of have to say, okay, technology is a means, the end is family, the end is your friends. What keeps me motivated? What keeps me motivated is the fact that I am not, I'm not Elon Musk, I am not Jeff Bezos, I did not build a giant conglomerate. What I am trying to do is you cannot have Microsoft, you cannot have Amazon without an undergrowth. It's like a forest. You don't have just the big trees. What keeps the forest alive is the little bushes that are under the trees. And if you have somebody like me, and if you have somebody like Riley, and if you have thousands of people like that, now you have an ecosystem. You have an ecosystem. If you only have, if you only have people who just stay in their lane and just do what they're told, you don't have a forest. You have like a grain field. And the problem with grain fields is that there's like one virus, one bacteria, and it just destroys them. That's what's happening with bananas.
Mhm.
No, you want to have your tech ecosystem needs to look more like a forest. Is it less efficient? A little bit. Is it more resilient? Infinitely. So if you want to know what keeps me motivated, I don't think it's about motivation. I just happen to have a passion for this stuff, and I am blessed that I get to make a living from it. What should get you motivated is find a problem that you think needs a solution. It could be your problem, it could be, your boyfriend's problem, it could be your sister's problem, and it could be your mom's problem, and you solve it, and maybe there's a technical solution. Even when there isn't a technical solution, technology can sometimes help, and that's the determination you have to make. And eventually what you will see is that if you solve that problem, it makes life a little better for people around you. And maybe that took a week of your time, maybe that took 2 months of your time, but the world is a little better. You got to keep that in perspective. We are currently living on one planet, hopefully two by the time I'm old,
Yes.
but out of trillions. And that keeps things in perspective. But in the here and now, what's important is that a person gets to say goodbye to their cat. A person gets to be able to attend class remotely. A person who is homeless gets a job offer because their phone was on, so they could take a phone call from their employer because they had a solar panel for their phone. You can't. If you look at history, there's the big broad strokes drawn by generals and dictators, and that's okay. But if you look at it, most of the actual movement forward has been done by 1,000 little steps. And if you can take just one, you've made the world a better place. And that's what most.
One important thing, because I'm representing developing nations, I meet with millions of students, young people,
Yeah.
and many policymakers and the government and the corporations. They feel threat if autonomous vehicles, technology comes, even AI comes, this, that, many things join with our industry. Maybe we will lose our job, many people go out unemployed, many questions. I'm giving you real feedback.
Well,
Real.
we will have to move towards some kind of UBI system. There's no way around it.
Okay.
It could happen in 20 years. It could happen in 100 years. My point, though, is yes, people will lose their jobs. Yes, people will become redundant.
Yes, honest feedback. Yes.
Don't. That's the thing. If you are a specialist in circuit design, and some guy in Palo Alto comes up with an AI that does circuit design, okay, now you lost your job. That's why I'm saying don't over specialize. Be good at something else. Be good at, I don't know, cooking if you want to. Just say, okay, my job's redundant. I'm just gonna stay home and cook, and my wife can go to work. You can say the main thing is that, and this is something I said earlier. 100 years ago, we were automating factories. 30 years ago, we started automating offices. Now we're automating engineering and law. There's a lot of, here's an example. My cousin became a lawyer because he said, a robot will never take my job. And what you see actually is that AI is actually doing a lot of paralegal work now. And that's okay. That's not a bad thing. What AI cannot yet do is be creative.
Very important. Very important.
There's been like an arms race for the brain. There's the brain drain where people, students who are very good go to other countries because they can get a better job and everything else. There's going to be less of that because the world is getting flatter in that sense. But it's not going to be about the brain drain anymore pretty soon because all the routine brain work will be done by AI. It's going to be about creativity and it's going to be about wisdom. And that's what we need.
Yes.
If you want to be a good engineer, be creative, be wise.
Very interesting. Even with my wife, I shared, like, if you are very good cook and you are creative, that is enough. You can sell your skills and knowledge, and this is very important. So, sorry, I think, can I take few of your minutes, because this is very inspiring. This is very interesting how we saw your project. This is very brilliant. So,
absolutely.
Yes. Like example, if we want to build up a better ecosystem, what you said, that you have 1,000 of specialized peoples. So let's World Talent Economy Forum. We are trying to develop an ecosystem with brilliant people like you, and with many of the brilliant people already, they are joining with us, and we are trying to developing a better ecosystem. So in that particular situations, how do you think, like, when we search for the better civilization, when we search for the better human being, what things we should consider first? What few things we have to integrate it with the local economy?
That's I'm gonna go back to my forest metaphor. If you have a monoculture, if you have a field of corn, you can get a lot of corn. You can make popcorn. You can make you can make polenta if you like. I don't know if they have polenta over there, but the first virus, the first bacterium, the first fungus that shows up is going to wipe it out. So what you want is that you want to get a situation where, yes, you have your giants, you have your Google, you have your Facebook, but in order for that ecosystem, for that technology ecosystem to be robust, to be available to change, to be resistant to change, and to allow itself to change, you're better off with a lot of small companies, because That makes sure that you have competition. That makes sure that there is no monopoly. Now, you will lose some efficiency because monocultures are efficient. But right now, we don't actually need that much efficient. I mean, take the stock market. 30 years ago, you would trade once every 2 days. Now you trade once every millisecond. And that was in the name of increasing liquidity. And it hasn't really done much for anyone else other than the stock market itself. That is a situation where your efficiency problem has been solved, and you should focus on resilience. The best way you get resilience, the best way you get disaster resistance, and we have actually seen this with the COVID-19, I think, is to have many options, is to let 1,000 flowers bloom. If you have 3 companies that make masks, if any one of them closes because they have to quarantine, hospitals go without. If you have a situation where you have a lot of small manufacturers and even makers who can make masks, who can make face shields, if any one of them or even any 10 of them get sick, the other 99 can pick up the slack. You're trading a little bit of efficiency for the ability to survive upheavals, and upheavals will happen. Sometimes they are artificial. There's a market disruption. Sometimes they're natural. There's a disaster. There's an epidemic. There's an asteroid falls on us. There's an earthquake. We need a diverse ecosystem for the actual planet, and we should copy nature in that sense, because we also need a diverse ecosystem for our industry. If you have a lot of small businesses, again, it's less efficient. But if anything bad happens, your recovery will be so much faster. You will have a huge advantage over people who over-optimize for a situation. And this is also engineering practice. Don't over-optimize. It applies to any one engineering project, and it also applies to public policy, I think. So you want to have a forest, you want to have a rainforest. You don't want to have a plantation.
Okay, this is very good idea. And we are almost close. Last few minutes, we want to know, like example, what do you think about the future, next 3-5 years, about the technology, about the techno policy? How will they will adapt with the whole world? And we want to know actually the global issues, the globalizations based on the technology.
Globalization has happened. We are seeing the backlash to globalization, if anything. My thinking is that this whole COVID-19 thing, what it did do is that it pushed the kind of telepresence we're doing right now. Again, I'm supposed to participate in a virtual hackathon today. We have had to learn how to operate at a distance because there was a virus that forced us to do it. Maybe there will be, climate change is going to be fairly important in the sense that even in the next 4 or 5 years, people think climate change, they imagine, cities underwater. No, that's not the case. But what you will get is that you will get saltwater in aquifers. So we're going to have to rethink our water distribution system. What you're going to get is that you're going to get a lot of people moving around because they can't make a living farming their fields anymore. So we're going to have to rethink our agriculture. My personal belief is that the next stuff that we have to do, and I live near Silicon Valley, so I see a lot of that. We need to see less, try to make a fancy gadget even fancier, and we need to tackle the actual problem. At the end of the day, nobody cares about iPods. Nobody cares about Bluetooth headsets. You can just use a phone jack for your headset and it will work just fine. What people care about is getting food on the table. And so what we're going to have to do as engineers, as technologists, is accept that the world is going to throw us a lot of curveballs, and we have to make our glove big enough to intercept them, because that's what it's going to take. That's what I believe it's going to take. Next 3 or 5 years, we're going to have to look at the things that we take for granted in an industrial society food production, water production, energy production, communication networks. And we're going to say, okay, how do I make this disaster resistance? Now, I wrote, a couple of years ago, I wrote a story. Speaking of which, again, have a hobby that you're not good at. In my spare time, I write. I am not good at it. I wrote a story. I think like maybe 30 people ever read it, even though I put it out for free. That's okay. It's fun. And what happens in it is that the end times happen. You know, the apocalypse. The Christian apocalypse. I'm in America, so I wrote about that because that's what they care about. And instead of accepting it fatalistically, the people in the story are like, okay, so we got all these natural disasters that are going to strike one after the other, after the other, after the other, which is kind of what this year has been like. Now, I don't believe in the end times, of course, but if you want to make a meme out of it. And so they're like, no, we don't want the judgment. We don't want any of that. We want to tackle each of these problems and sort them out and cancel the apocalypse.
Yes, this is actually a brilliant idea that how we can build up our ecosystem. Already audience, let's say Mohammad Shoel Rana also want to give you thanks. After this pandemic situation, robot maybe they will add in the future workforce. So we need more innovations from you and from your teams. Hopefully by World Talent Economy Forums, we can do more integrations with the modern technology, and we can develop a better ecosystem together. So thank you for your time, especially how our audience see different kind of projects, different kind of informations, solar projects, robotics projects, and autonomous projects, many things. So we strongly believe that this is the way how we can improve, and this is the way how we can build a better ecosystem. Thank you for your time. Thank you for your everything. We really appreciate your things, and as per my commitment, after these things, I will share your YouTube channel with our audience. So hopefully they will know many things about your project. Thank you.
You're very welcome. Can I say one last thing?
Yes.
Okay, you want to be a good engineer? Get your mindset to where you should be ready to save the world.
Mm-hmm.
That's all I got. Cancel the apocalypse.
Yes.
Seriously.
Yes. This is very good thing. So we need to create a positive mindset. So when we have a positive mindset, definitely we can change many things. So thank you for your time, and thank you for your brilliant stuff. So hopefully we can integrate it together. Thank you.
You're very welcome.
Thank you.